Hello everyone, welcome to my channel. In this video, the topic name is electricity. This is the first class of electricity. It's something like a foundation course for electricity. We'll discuss only the basic topics here. If you are new to this channel, please press subscribe so you are get updated with the new videos. And if you like this video, please press like. And if you want to share with your close one, you can share this video. Let's start with the topic. So the topic name is electricity. Okay, so electricity is it is a branch of science. It is a branch of science that deals with the motion of charge. That deals with the motion of charge. Okay, so there are many other branches of science, but a specific branch which deals only with the motion of charge is electricity. Okay, now for the moving of the charge, what is compulsory? For moving of a charge, you need a circuit. A circuit should be there so that moving of charges take place from one position to another position. Okay, so now we'll see with the other formula. The formula for the charge is given as Q is equal to Ne. Okay, where N is the number of electrons and E is the value of the electrons, which is 1.6 into 10 to the power of minus 19 coulomb. Okay, now the next topic comes with if a question is given like this. Okay, so you have to find the value for the 3 electrons, or you can say 4 electrons. What you have to do, the charge for the 3 electrons is Q is equal to 3E, which is 3 into 1.6 into 10 to the power of minus 19 coulomb. Okay, it will give us 4.8 into 10 to the power of minus 19 coulomb. Now here what we have seen, I am writing C here. Okay, this C stands for coulomb. Okay, this is the unit for charge. Now we'll solve this other problem 4E. Okay, now the Q is equal to 4E, which is equal to 4 into 1.6 into 10 to the power of minus 19 coulomb. You can write it as 6.4 into 10 to the power of minus 19 coulomb. Okay, so with this formula, if any of the question is given in your exam, you can easily find through this. Now let's go to the other topic. The topic is current. Okay, we have seen the motion of the charges, but the question comes here. Now what if there is a rate of flow of charge? Okay, what do we call with that? So current is a rate of flow of charge. Okay, we know there is a motion. Okay, but how much is the rate? Okay, so that is called as a current. So this we can write as rate of flow of charge. Rate means that is nothing but divided by t, time. So flow of charge is Q by T, and the current we can write it as I. Okay, and so the SI unit for charge is, okay, now we'll say the basic formula here. Q is equal to, you can write as Ne. You already know the formula of charge, that is Ne, and divided by time. Now we will see the SI unit. The SI unit of charge is coulomb, whereas for time is T. So you can write it as coulomb by time is ampere. Okay, so coulomb by time is ampere. This is the current, rate of flow of charge, it is a current. Okay, now next topic. The next topic here is, we have seen what is charge and we have seen the motion of charge, the rate of charge. Now we also know that it will take place in circuit. Now to make a circuit, there should be easy flow of charges. The material which is making easy flow of charges is called as conductor. So this is the physical material which is used, okay, to, it is the easy path, it is the easy path for flow of charge, for flow of charges. Okay, now how can you make a conductor? Conductor are based on different materials. Okay, some of them are metal, you can use metal in making the conductor, aluminium, copper, okay, etc. So basically all metals you can use, iron also you can use in making the conductor. And what does conductor do? In conductor you can, there is a easy path for flow of charge. If you have any doubts, please comment in the section below, or you can also join my Telegram channel. Okay. Now we have seen the easy flow of charge. Now what if there is some opposition is there in the flow of charges? Okay. Okay. If material is made which can oppose this the flow of charge, that is called as a resistance. Okay, and the resistance is represented with the symbol R. The resistance is a symbol R. It is nothing but the opposition to the flow of charges or current. Okay, opposition to the flow of charges or current. Now there are only two conditions. Okay, mainly there are the two conditions how it can be done. The first one is the due to the first behavior. Due to the first behavior of material. Okay, what kind of material you are using, it depends on that. Okay, for different material there is a different resistance, so this resistance will oppose the flow of charges or current. Okay, and the second one is the, if there is a collision between the motion of charge. The second is the, if there is a collision between the flow of charges. Okay, we have seen what is a conductor. First we have seen the current, charges, current, then conductor. Now in conductor there is a easy flow, but what if there is a opposition? That comes under the resistance. Okay, now to complete the circuit, power source should be there. Okay, battery source, which is called as a battery. Okay, this is the source for the circuit. Okay, so you can also write as a source of charge. Okay, basically there are the two types. One is the dry and other is a liquid form of cell, which is called as electrolytic cell. Okay, so if we are having two, that is, one is the dry cell, one is the dry cell here, and another is the liquid form of cell, which is known as also electrolytic cell. Some of them examples are this battery, pencil cell, button cell, etc. Okay, now will come the next topic, that is the electrostatic potential. Okay, the topic name is electrostatic potential. Okay, now we will use this small diagram here. For example, here at point one charge is there on this line. Okay, and some other charge is there at infinity. Another charge is just infinity. Okay, now what we have to do, what we are doing here, we are bringing the charge, okay, q naught is equal to 1 unit charge, okay, from where infinity to this point at point P. So what we are doing, we are bringing the unit charge from infinity to this point, and now what we have to do, we have to find the electrostatic potential at this point P. Okay, so it can be written as Vp. The symbol which we are used for electrostatic potential is V. Vp is equal to work done in bringing the charge from point infinity to P, and what kind of charge we are using, that is nothing but Vp Q naught is equal to Q naught is equal to 1, as we are using 1 unit charge. So work done from bringing the charge from infinity to P by Q naught is equal to 1. Okay. With this formula you can find the electrostatic potential at point P, and now we will see the SI unit here. Okay, so work done, for work done we will write as a joule, and for charge you can write coulomb, so joule by coulomb, you can write it as what, volts. Okay, fine. Now there is another topic in this one, that is called as a potential difference. Okay, this also with the represent with the symbol V, volts. Okay, to understand this one, we'll draw a circuit here. See, this is a basic circuit. Okay, in this one there is, you are having a bulb. Okay, and here the battery source is the terminal. This big line is the positive terminal, and the small line is the negative terminal. Okay, and here K is the switch here. Okay, the switch is used for on off purpose. Okay, now we will see the conventional sign. Okay, the conventional direction of current flow. Okay, the conventional direction of current flow is from positive to negative. This is the direction of the current flow. Conventional direction of current flow is from positive to negative, and the direction for the flow of electrons, okay, is from negative to positive. Okay, so you can draw like this. If this one is positive here, this is for I, and it's for negative, this is for electron flow. So flow of electron is from negative to positive, and the flow of current from positive to negative. Now coming to the topic, what we have to find here is, you have to find the potential difference, okay, from point A and point B. The potential difference of moving a charge from point A, from moving a 1 unit charge from point A to point B. Okay, so how you can write like this? You can write like this: V A B, that is work done from bringing the charge from A to B by Q naught is equal to 1 unit of charge. Okay, so this is how you are going to find the potential difference of point from A to B. Okay, now there is one more topic, it is called as an EMF. Okay, that is electromotive force. We'll write here. EMF. EMF is nothing but if you want to find an EMF, it is taken from the one terminal to another terminal of the circuit. Okay, so you can write as a work required to move a unit charge, move a unit charge from one terminal of circuit to another terminal. Okay, this is the EMF, electromotive force, and what we have seen in the above is the potential difference, which is between these 2 points, but not from the terminals. But in the EMF terminals, you have to find from this one terminal to the another terminal of the circuit. Okay. Now we will see what are the basic symbols. Okay, what are the basic symbols we can use in electricity? Symbols in electricity. Okay, if you are watching this video till now, thank you so much for watching. Please like this video and share this video and subscribe to my channel. Symbols in video, we'll start with this one. As we have seen, for the conductor you will draw just a straight line, and for the resistance, what you will do, for resistor you will try this one. This symbol is mean resistor. Okay, this symbol is used for representing a resistor. But what if you want to represent a variable resistor? So what you will do, you will draw the resistor same thing, and in that one, on that one you will draw this arrow. Okay, which means that you are using a variable resistor, not a fixed resistor here. Okay, but what does your circuit requires to keep on changing the resistor from either increasing or decreasing? So for that one, what you will do, you again will draw a resistor like this and will point an arrow like this. Okay, if it moves onto the left side, okay, at this side it will decreases, and if it moves onto the right side it will increases. The value of the resistor increases. Okay, and this symbol is called as a rheostat. Okay, so this first symbol is the resistor, second is the variable resistor, and the third one is the rheostat. Now coming to the other symbol, what if you want to represent a battery source? Okay, you can represent like this. This one is a positive, this is negative, and this is the battery source. What if you want to represent many batteries? Okay, so that is called as a cell. As you are using many battery source, that is called as a cell. Now coming to other, which is called as a here. Okay, you can either write dot or you can write K here. It is called as a switch. It is used to switch on or switch off the circuit. Okay, now if in your circuit, if you want to measure the current, okay, if you want to measure the current in your circuit, so what you will do, you will use an ammeter here, and it is drawn with the symbol like this A in the middle. Now what if your circuit required to measure the voltage of the given points? So at that one you can write like this V, and it is write as voltmeter to measure voltage and to see the potential difference. So ammeter is used to measure current, and voltmeter is used to measure voltage or potential difference. Okay, now coming to the other important topic here, that is called as a Ohm's law. That is called as an Ohm's law. Okay, now Ohm's law states that the current in the circuit, I will write it down here, the current I in the circuit is directly proportional to the potential difference applied applied across the terminal of circuit. Okay, so Ohm's law states that the current I in the circuit is directly proportional to the potential difference applied across the terminal of the circuit. It is only valid if unless and until the temperature or physical condition remains unchanged. Okay, so what is Ohm's law? The current I in the circuit is directly proportional to the potential difference applied across the terminal of circuit. Okay, so which can be written as, based on the law we can write as I is directly proportional to V. You can also write as V is directly proportional to I. Okay, so voltage is directly proportional to the current. Now we will use some graph diagram here. Here the x-axis you can write as current, and the y-axis you can written as voltage. Now we will draw straight, as you can say, directly proportional, so straight line will come. This straight line is nothing but the opposing of proportionality. Okay, it is a constant of proportionality which is called as a resistance. This is a straight line. If you want to find point at this, okay, so this is the theta here. As you know, in the mathematical formula you can use slope here. Okay, at this point the distance from this to this is V, and from distance from origin to this point, which is on the x-axis, it is the I. Okay, so you can find the slope. The given formula for the slope is tan theta is equal to V by I, as you know in the mathematical terms. Okay, now the formula is given as V is equal to IR. Okay, so this R is the constant of proportionality. Whatever the proportionality you are getting is called resistance. Okay, now as you already know, tan theta is equal to V by I. Here also with this one you can write V by I is equal to R. So slope is nothing but the resistance. Okay, so if V increases, I also increases. Okay, unless and until, it is only unless and until there is a temperature or physical remains unchanged. Now we will see two formulas. Okay, based on that graph diagram we will find the resistance. Okay, if a question is given, okay, like this, a graph is given. Okay, a graph is given here. This is the I and this is V and this is graph. Okay, here A and B. Now the question here is, which is having greater resistance? A or B? Now what you can do, by saying it you can estimate the angle. Okay, this is theta 1 and this is theta 2. Okay, so with this one we can say that the slope of B is greater than slope of A. Slope of theta 2 is greater than slope of theta 1. So therefore slope of B is greater than slope of A. So that's why RB is greater than RA. With this you can easily say the who is having greater resistance. And again the last question here is, the same, this is A, this is B, and then here what we will do on x-axis, we will use 1 by I and here 1 by V. Now if you find the greater resistance, who is having greater resistance, A or B? So what you will do, again you will draw the angles here, theta 1 is a theta 2. Okay, now from the previous question we can say that the slope of A is greater than slope of B. Okay, the resistance we can say as a slope of A is greater than slope of B. There you can also write as tan theta 2 is greater than tan theta 1. But here you can see that theta 1, the slope of B we are using is 1 by I, and here at y-axis 1 by V. We have to concentrate on the coordinates also. If we neglect the coordinates, then your answer will become wrong and you will lose your point. So here what will happen, as it is in the reciprocal, okay, theta 1 will become 1 by RB. Theta 1 is nothing but 1 by RB, whereas theta 2 is nothing but 1 by RA. Okay, so what if you ping cross here, RA, sorry, you can write RB is greater than RA. From, like in the previous question you got RB, but B was in the upwards, but here what we are getting, resistance of RB is greater. Why? Because as you are using both the coordinates in the reciprocal form, that's why RB is a greater resistance, okay, when compared to previous one. Okay, if you have any doubts, please watch this video once again. Okay, then also if you are having doubt, you can comment your doubt below. and thank you for being till the end of this video. Thank you so much, and we'll upload the next class soon. Okay, thanks for watching.